Tuesday of next week, and we'll talk about it then. The table stuff I'm not putting in the next test anyway, but I still want you to do the homework and see what it is. It's basically like on steroids. It's like standard integrals and steroids. So I think there are about 130 standard integrals that are already done for you, and we'll show you how you can use the table and to get the answers to all sorts of integrals. Didn't we have an issue once where there was a secant cubed, and that was kind of unfair? That would be an example of when the tables would get used. When you do an integral and then you get to the end and you do not have any obvious U-sub technique that's going to get you out of the hole. So we go and pick someone else's brains, and they've done it for us, so we use their answer. Right, well, let's start with this fella. This is one of the questions where it asks you to do a U-sub. So, give me a U-sub.
E to the x.
And off we go. So you differentiate with respect to x. I want to take this question all the way through. There's the crossover. I think one of the things you might want to do with these rather weird ones towards the end is not turn everything in sight into use quite yet. So I'm going to leave it untouched for one more line. All of this stuff. Replace the dx. That allows me to see that these cancel, and so I get a 1. And now I'll worry about this guy and then this guy in terms of e to the x. Well, e to the x take away 2 is just a u take away 2, agreed? What's an e to the 2x going to become in relationship to this?
U squared.
Great. Would you agree that this is a standard run-of-the-mill type of partial fraction question? Great. So I'm going to go through it anyway. So we're going to take this fella. Now, since this guy contains a square term, we have to be a little bit more careful about the two baby fractions, the guys that are called the partial fractions. Are you comfortable about why the first one gets an A, but the other one gets 2 terms? Great. Now, just like every other question, is it the next phase to take these two guys and put them back together again? And the way that I've said before, and I think it's useful for me, is to look at what this guy has, and in particular, look at what he doesn't have. He doesn't have an x squared plus 4, or a u squared plus 4. This guy doesn't have a u minus 2. So we're kind of at that phase. Now I'm going to skip a line and say the top terms look like this. And they're equal to, in this case, 1. The bottom term is going to be the same as that. So basically, I just didn't write the whole fraction, then use the top. I think that line's easy to miss now. You've seen enough of them. Pretty standard. You pretty much do every question that same way. Now we come for the thought process stuff, where we have to choose a u. Now, there's lots of u's you could pick. You could pick 0, for instance. You could pick 2. But only one of them is actually a good idea. And so the order is more important here. When these guys in the bottom are all linear, it really doesn't matter which one you take care of first, second, or third. You're going to get the right answer. But in this case, who is the first U that you need to choose? What number?
2.
For those who are still thinking about that, could you tell me why you chose 2, which is the right answer?
Because it'll cancel out the BU plus C, leaving you with just A.
Yep. Wouldn't this piece here basically be 0? So that disappears. So when you're thinking about who to pick, kind of ask yourself that question. What number for you would make a whole chunk like these two go away and just leave me with one variable? So what do I have? I have A, 1 squared plus 4 is 5, plus a whole load of nothings, right? Well, that tells me who A is.
U is 2, not
2
1.
squared.
Oh, shooting space. Did you all catch that deliberate mistake?
I made the same mistake 2 seconds ago.
Okay. Well, I'm not the only one then. Well caught, thank you. Now, that means I know A. In these questions, every time you find something, rewrite the information, but use what you've just found. And that will help you in a couple of ways. First, you now know that you've only B and C to find. And secondly, when you choose the next U, it will work. If you left an A there, it gets really weird looking, and you might not be able to make it work. I think this next value of U is pretty standard, at least when there's a U squared plus 4. Who do I choose this time? And there's only one guy. Agreed. And won't that make this disappear? And so I'm only left with a C. Oh, do you notice that the A is gone? It's a number now, so I don't want you to worry about A. So 1 is equal to 1/8, nothing plus 4, plus 0 times C, which is just C, times -2. So I get 1 equals a half, take away 2C. If you subtract a half from both sides, and that gets me -1/4. Kind of cool. Right, moving on. Now that I know what C is, I go to this line and replace C by -1/4. So I now have 1 equals 1/8 U squared add 4 plus BU minus 1/4 times U take away 2. I need to choose a U. Now remember, the goal here is to find out what B is. So don't pick 0 and don't pick 2. They've done their job, don't use them again.
1.
Yes. Did you read my mind? Why do you think I picked 1? Because 42 would work.
That we haven't used yet. And
That's
it does
true.
at this point.
Yeah, I want to make my life easy. The bigger the numbers, the more likely I am to screw up. So what do we get? We get 1 equals 1/8. 1 squared plus 1 makes that 5. Plus, well, it's helpful here as well because won't that just be a B? Take away 1/4. Multiplied by what? -1. So I have 1, 5/8. Distribute that is -B plus 1/4. That's 2/8, so I get 7/8. Subtract 7/8 from both sides. And that gives me the last guy in the set. I now know everybody. A, B, and C. So Where's my little integral? Here we go. So this integral here can be split up as 1/8 a, that's a, and then we have some b's and c's. So where's b? It's floating around. B is a bit messy. It's -1/8 u, -1/4 over u squared plus 4. And actually, I'm going to split these guys up into 2. In fact, I'm actually going to split these guys up into 3. That's the A. I've just decided to use the negative outside. That's the B. And that's the C. A, B, and C. Now, each one of these guys, we will integrate. The first fella looked like that. And that's 1/8 the natural log of this guy. The second guy looked something like this. I'll come back to him. And the third guy, I'm going to actually stick up the top here. Bit small, but that guy there is an inverse tangent. So I know that one, I know that one. This is the middle one. What method am I going to use to find this guy's integral?
A W sub?
Yeah. I'm going to use u squared plus 4. So when you differentiate with u, when you do the crossover, and then you isolate. So this guy, stick a little negative there in case I forget it. It's going to be 1/8 u over w times 1/2u dw. I know those u's cancel. What kind of fraction is this going to get me? I have a 1/8 on the top and a 2 on the bottom. What on earth is that going to become? 1/8 on the top, 2 on the bottom. What single fraction does that become? You may have said it, but I can't hear you. I think I heard it. And guess what? Let's just pull the damn thing out. I probably should have done that a lot earlier. Can we just call that -1/16 and it's out the road? So it's integral. Right, a half on the top. It's a bit like saying a half divided by 2. So -1/16 the log of w, which becomes -1/16 the log of u squared plus 4. And so my original integral, which was this guy, has now became that guy, and that guy. And so in no particular order, 1/8 the natural log of this guy, take away 1/4 the inverse tangent of that, -1/16 the natural log of u squared plus 4, add c. Is that answer right? Let's phrase it a different way.
The U's back.
Mm-hmm. Now, if this was a test question and you got all the way to there and that's what you wrote in the box, you know, where the answer goes, you'll get 0 out of 20, according to WebAssign. If you show me all this good working and that was the only mistake that you made, you'd get 18 out of 20. Can I sell you on why I need to see working for your test? Because if all we see is the wrong answer, it's kind of hard for me to do much with it. And it's not fair for me to say, well, I know Janice. I bet you she just forgot to switch it round. But John's not that good, so he just guessed. You know, I'm not going to put a value judgment on it. It's not fair. So if I don't see working, I can't make an assumption of what you may or may not have done wrong. So if you don't show me working, I can't do anything. But if you do show me working, I will give you as many points as you deserve. Hopefully most of them.
Can you explain how we got to the 1 plus u squared underneath our c term?
1 plus u squared underneath our c term.
Yeah.
This
How
guy?
did we get 1 plus u squared when we had u squared plus 4 under them both?
Darn it in space. That's a 4. Okay. That guy there is a 4. Right? Okay. Which means don't you get a u over 2 and that becomes an 8th. Which means this is an 8th and a u over 2, which makes this an 8th. Fixed. It was just me. Well, if I had done this answer, I would have only got 18 out of 20. My mistake was just a 4 became a 1 somewhere halfway through the question. Easy done, unfortunately, for me at least. But that's why you should show working, right? Got a lot in that question, so you know you're not going to get many of these in the test. Agreed? You know, we've got whatever, 20 minutes to do one question. You only have 2 hours. You know, you do the math, it ain't going to work. But you will get one. I guarantee you are getting a question that involves partial fractions. Who knows if you'll get one of those? You may get something different, of course. Here's the next question. Haven't covered 12 yet. It asks you to find the area under the curve from 1 to 4, but that's just a disguised way of asking you to find this integral. This guy is not ready yet to be a partial fraction question. And there must be another one somewhere, I just can't seem to find it right now. Remember we spent some time doing long division just to do a couple of questions? Do you recognize this as one of those couple of questions? What about this guy here that tells you you need to do a long division first?
Our powers are the same.
Yeah. If this is the same power of that, or even worse, if this is a bigger power than that, in both those situations, you're going to do long division. It's not the biggest long division in the world, thank goodness, but it is technically a long division. So let's see what the working for that would look like. Well, you got this fella divided by x squared plus 6. Why is there a funny gap in the middle?
Because there's no x to the first term.
Right. I don't like this, but for some people, putting 0 x's helps. So if that does help, feel free to do it. Me, it just, I don't know, just looks funny, I guess. Right. You need all the terms because when you line things up, you want a place to put an x or an x squared or whatever, if you need it. I suspect strongly this one doesn't, but that doesn't matter. Now, cover up everybody. Question.
It was originally in the denominator 5x minus x squared. Is there a reason why it's only 5 minus x squared, or is that just
Nope.
a mistake?
Just a mistake, but at least you caught it early. Are we ready? I'm going to tell you, I'm going for sympathy after this question. I'm going to tell you a story. You see this guy here? What do you need to multiply negative x squared by to make it a positive x squared?
-1.
Negative
Yeah.
1.
Negative 1. Not the biggest long division question in the world, right? But here goes. Negative 1 times 5 gets me negative 5x, which I'm going to put underneath the x's. And negative 1 times this gets me positive x squared. And then I subtract. X squared, take away x squared, gone. No x's, take away negative 5 gets me positive 5x. 6 take away nothing gets me 6. Which means that this fella here is actually negative 1, the quotient, plus the remainder. And while I'm at it, why don't I take out a common factor of x? Can you see the guy that we are going to use the partial fractions on now? Can you see where he lives? And what's that going to be? That's just going to be negative x in a little while. So let's focus now on the partial fraction part. Well, let's say not yet. You may know I wear glasses. It's pretty obvious. I have a duff left eye. I was born with it. Can't see a darn thing out of it. Well, virtually nothing. If I give you an example, if I cover up my right eye and I look at you, if it was, well, on the screen it's worse, but if I looked at you across the room, I would only be able to tell it was a person there. I couldn't tell even if it was a woman or a man. That's how bad my eyesight is. Now, a couple of the problems I have with one eye is that scanning horizontally is quite difficult for me. And one of the things I do very often badly, as you probably noticed, is that I write down a question and then I scan over and I misread what I thought the question said. And so you lose a 5, right? And so instead of 5x, and an x squared plus 4 becomes an x squared plus 1, because when I scan over, I think I'm seeing an x squared plus 1. And then when I scan back to where I'm writing, my brain has told me something else. And so that is it. A couple of other things. I've never seen a 3D movie in my life. I've been to 3D movies, but I don't see 3D movies. Because you need different lens on each, don't they? They filter it in such a way. It's not pleasant for me to do that, because my brain gets really annoyed because of the information's kind of basically blurred. So that's not fun. Parallel parking is interesting, because depth perception is quite difficult when you've only got one good eye. And door handles are quite fun. I sometimes miss door handles. You know, I was like, and they're not there. And sometimes I miss door handles by banging my hand into the door because I misjudged the distance. So if you ever see me parking, I take a long time, parallel parking, but I'm very good at it because I'm extra careful because I know I can't tell depth perception well. So I'm very, very slow. There, that was a good thing to share, right? But you are not to feel guilty about telling me when I screw up. So if I write x squared plus 1 and it should be a 4, you tell me, right? Or why did that 5 disappear? You tell me, right? Because you know it helps everyone, including me. So back to this guy. We are going to split him up, aren't we? But isn't this going to be the relatively simple version? Just two linear terms, right? And this guy, right? and this guy, one of each. And I'm now going to multiply this guy by 5 take away x. And I'm going to multiply this guy by x. And so we have a 5 minus x plus bx should be the same as the top. When your partial fractions are linear, things are a bit quicker. Can't I just pick any number that works and then the other number that works and I'm pretty much finished? So I don't have to do that, fill in the answer that you just got and rewrite this in a different form. Don't need to do that. But we still need to pick the right guys, don't we? So give me an x to choose. That sounds like a plan. 5 times 5 is 25. 25 plus 6 is 31. Oh, my bad eyesight has got nothing to do with the fact I can't count. Right. I've got a great believer that all the best mathematicians can't count. Probably not true, but I have that as a theory at least. Now, that guy becomes 0, and this guy becomes 5x, and yikes. I don't like that answer, but there we go. B is, try to think ahead here. B is 31 over 5. We good with that weird, ugly fraction? Okay. I need to choose another one to get the second guy then. Would we all agree it's 0? 0 on this side just gets me 6. 0 on that side. 0 on this side gets me, what, 5a? So looks like a is going to be 6/5. So this is going to be the integral from 1 to 4 of -1 plus a over x plus b over 5 minus x dx. That's going to be the integral from 1 to 4 of -1 6/5 over x 31/5 over 5 take away x dx. You all comfortable with the values? They look good. Okay, let's integrate. -1 gets me -x. What does that fill in the middle get you when you find his antiderivative?
6/5.
Agreed. What's this ugly thing here?
31/5 the natural log of 5 minus x.
And here's something that you might have missed. Why is it negative, that answer? Because typically it's positive. If you do the linear shortcut, is it not -1? And isn't the answer when you do the linear shortcut 1 over the number? Isn't 1 over -1 -1? If you don't like that, why don't you just do a u sub 5 minus x and convince yourself that that is negative? Now, if you plug in 4, you get -4 6/5 the natural log of 4. Take away 31/5 the natural log of 1. Subtract, plug in 1, 6/5 the natural log of 1. Take away 31/5 the natural log of 4. That's not a very nice looking answer. And we're not allowed to just leave it that way because we don't want to make it better. We have to make it better. So let's see what kind of things we can do to make this a little bit nicer looking. What's the natural log of 1? What number is it? Right, so can I ignore that one and that one? So what have I got? I've got -4 plus 6/5 natural log of 4. Take away a -1, which is add 1, and take away that guy, and it's add 31/5 the natural log of 4. Better, right? Nicer. Can we do anything else?
Add the 1 to the -4.
Anything else?
Make it 37/5 natural log of 4.
Would you agree that's probably as good as that's going to get? At least it's a lot nicer.
Right.
Give me a few seconds if you're still writing that down.
Is that supposed to be 37/5?
Is that supposed to be? Yes. Just going to the homework here and having a quick scan. I think I've covered all the major stuff. There is a couple of true false at the end we're going to look at, and that'll be the end. Okay, stop sharing and go and look at screen 2. True false are nice because there's a 50-50 chance that you're going to guess it right. But it's better if we know if it's right. Is it true, this is question 13, that this fraction can be broken up into this format? You're shaking your head. Good, Kathy. You want to tell us why? That's the right answer.
Because if we were to distribute the x on the top, we'd have an x cubed.
Right, so
We'd
shouldn't
have
you
to do
need
a
to
division first.
Exactly. So you would say false. Is 14 true or false? Could you take that fraction and break it into those 3 partial fractions? Great. Where's the plus and -3 thing coming from?
-9.
Yeah, it's factoring x squared -9, isn't it? Bear in mind, see if you ever see a partial fraction and it says x squared -5x -6, you know, something like that. We always think factor, right? 2 linear terms. You're never really going to, it's not going to end well if you leave it as an x squared, you know, -5x -6. It's just a +6, whatever. It's not going to end well. 15 sneaky, last one. Then we'll talk a little bit about the test. True or false?
True. Oh no, not false.
What's missing? And it's so easy to miss.
The x
Isn't there-
squared should be under a bx plus 3.
The x squared, say it again.
The x squared should be under a bx plus 3.
No, that's not what I'm thinking.
The A should have an X.
Shouldn't it be ax plus b and then b and then c?
Yeah, you could call it ax plus b over x squared. Or you should have probably just called it a over x plus b over x squared. Remember the rule when it was x minus 1 squared? You had an a over x minus 1, but you also had a b over x minus 1 squared. Remember that rule when it's identical terms squared? You have 2 terms, one with the single power, one with the double. Let me write that down because that is only for auditory learners. Let's show you what I'm getting at. Maybe what you were saying is correct and I wasn't just picking it up right. But if you had say that the split would be that guy, and that guy. This term here generates two guys. Now, even if that guy is an x squared, it's still true. This would split as an a over x plus a b over x squared plus a c over x plus 7. Anytime you have a squared term, it splits two ways. One with the single power, one with the double. You're not going to get this because we only go to squares, but to give you an idea of what could happen. Do you know if there was a cube? We don't do those questions, but if there was a cube, you'd get a +1. Then you get +1 squared. And then you'd get +1 cubed. And then the last guy would be, as always. That's what made that false. Now, could you actually do a over x squared plus b over x minus 6? Yes, you actually could do it. And it'll give you numbers. They'll just be wrong. Right? They just won't actually be the partial fractions that, if you put them together, would give you the original. And if you took the two wrong answers, suppose it was 1 over x squared plus 2 over x minus 6, right? So if you took the wrong answer, if you stuck them together, you would not get x squared plus 6 over x squared over x minus 6, right? It wouldn't work. So I guess, trust me, I'm a mathematician, will have to be the rule. That's how you have to do x squared or x minus 1 squared. Now, if it's x squared plus 4, don't you then do the ax plus b trick? So if you ever had that guy, right, you do that. Are we cool with that? Right. Well, just I don't think I've done it. Will you say hi for attendance? While you're doing that, I'll get myself set up. Okay, looks last one. Well, we all know that the test 3 is going to be due on Monday. And test 3 is going to consist of 4 sections. Chapter 7. It will finish on the stuff that we've done today, which is partial fractions. And there will be no homework. Just reminding you again, there will be no homework on tables, and there will be no test question on tables. So the only thing you need to prepare for is what we've done in our chapter 7 stuff, right? Any questions about that? It seems straightforward. It will become visible on WebAssign at 11 o'clock. And it will finish at 1. And for those people that time schedule doesn't work for you, and will you just shoot me an email with your times, and I will arrange a different time for you to do the test. If any of you get access services and you get extra time because of that, will you remind me as well so that I can set up WebAssign to give you the extra time? What else? There'll be a very short things you need to know to do the midterm, to do the test, which is basically a regurgitation of what I did the last time. So, you know, what you can and can't do, we all know that. The test will be chronological, so you know the last questions you're going to get are to do with partial fractions. What's the first question you're going to get?
Parts by integration.
Say it a bit louder, please.
Parts by integration.
Oh, so we have integration by parts. Been a while, hasn't it? 2 weeks. What else have we got? Trig substitution, you know, like sine cubed theta, sine squared theta. And the other kind, I call them x subs. You know, the square root of x squared minus 1 over x cubed, that kind of question. Where you do x equals, you know, 2 cosine theta or whatever, that type of thing. So make sure you make good notes. For instance, see for the x subs, wouldn't it be a good idea to write down which x sub to use in each situation so you know what that is? I would also strongly suggest that you get a copy of all the trig identities. You know, like what secant squared plus 1 is and things like that. Or I should say tan squared plus 1, right? Whatever. That's it. I can't think of anything else. Is there something I should have told you and I haven't? Do you feel you know?
Sorry, will the table be on our final?
You broke up there. Something final.
Will the tables be on our final?
No. The final exam? No, you're not talking test 3 here, right? You're talking about at the end of the quarter.
Yeah.
Yeah. No. There'll be homework on it, and we'll do it on Tuesday. But I won't ask you any test questions, so it won't be in test 4 either, and it won't be in the final.
Okay, thank you.
There's lots of better things I could ask you, and I don't want to use that up. Plus, it's a pain in the butt because I have to supply you with, well, I've actually got it online if you want to get a heads up on it. The table, the pages from the table that you would use in that section. Are we good so far? Is that the only other question? Well, have a nice weekend, but not too nice a weekend because you've got to practice for your test and you've got to get your homework done. Bye-bye. Oh, anybody who needs any extra help, you just hang about. Maybe a homework question you want to go over. I'll be here for you.
Okay.
Okay, looks like we got Javon, Matthew, and Samuel. I'm going to do Matthew first because he sent an email, so he gets kind of first dibs. What's your question, sir, Matthew?
Okay, so I'm stuck on number 9 after I separated the terms into, I got a over x plus bx plus c over x squared plus 2.
Okay,
And
you want to tell me that question? I'll do it from scratch, and then maybe you'll figure out where it went wrong. So what was the
it's,
original?
the integral of x squared minus x plus 8 over x cubed plus 2x.
Okay, I'll switch over and we'll go through that. Do you mind if I use this as part of the video so other people who come in?
Oh, that's fine.
Sure. Good. So, you factored it. That's what I heard. By taking out an x, I'm assuming.
Mm-hmm.
You got that, right?
Yes.
Okay, so let's do the partial fraction stuff and see how that goes. So x squared take away x, add 8. There's going to be an x squared plus 2. And that's going to split. Well, it's going to split as an a over x plus a bx add c over x squared plus 2. You comfortable with the 2 splits?
Yes.
So that wasn't your problem. I put some brackets around some things. Now I'm going to put them together again. This guy is missing an x squared plus 2. And this guy is missing an x. So the top line becomes a lots of x squared plus 2, add this fella. So bx add c, I guess, times x. And that's going to be x squared, take away x, add 8. That'd be good so far. That's good. So let's choose an x. These kind of questions, there's one right x and no other. You have to pick this one before you do anybody else. So who are you going to pick?
I chose x equals 0 first.
Perfect choice. 0, 0, 8, you get 8. 0 squared plus 2 gets you 2, so that's 2a, and that's nothing. So we now know 8. So I go back here, and I replace the a with 4. So it's going to be x squared, take away x, add 8. 4 lots of x squared plus 2, add bx, add c, times x. And this is where you got stuck, right? Because the most natural choice would have been, and typically is, 0. But in this pain in the butt, 0 destroys that, and we already know that. So you might think, well, how do you do it? You have to adapt. What do I mean by that? I'm going to choose x equals 1. And that's going to get me 8. And that's going to get me 1 and 3. That's going to get me 12. And this is going to get me b add c times 1. So 8 is 12 add b add c. That gives me this relationship. I'm now going to choose another x. There's nothing significant about 1. You know, I could have chosen 2 or 42 or 1 and minus 1, and it wouldn't matter. I'm just picking small numbers because I tend to do fewer mistakes when I do small numbers.
All right.
So my second choice is -1. So -1 squared is 1. That becomes +1, so it's 2, so I get 10. And that's still 12. And this becomes -b add c times -1. So what I now have is 10 equals 12. 2 negatives make a plus. I get that. And now you get -2 is b, take away c. Do you see a system of equations from Math 99?
Oh, okay, yeah.
And so if I call this equation 1 and I call this equation 2, if I add these two together, won't that destroy the c's?
Yeah.
And so add these two together, you get -6. Add these two together, you get 2b, and these kill each other off. So I now know b. And because I know b, can't I then plug it into either this one or this one and get c? Let's plug into this one. -3, add it to that side's 1. Eventually c is -1. And now I know c. So this integral becomes a, which is 4 over x, plus -3x -1 yikes, over x squared plus 2 dx. I will split that up as a 4 over x, the integral of, let's stick the 3 outside, that guy, and that guy. Now this guy gets you 4 natural log of x's. This guy is messy. I think it's just the way that WebAssign assigns constants. If that was 4 or 9 or 16, it'd be easier to see, but isn't that 1 over the square root of 2, the inverse tan of x over square root of 2? You know, 2 is square root of 2 squared, right? It's much nicer when it's 9s and 25s, but you can do it with 3s and 2s as well. And how am I going to finish that middle guy off?
Oh, U sub.
And then off you go. We got another one?
Oh, that's it for me. Thank you.
Okay, if you want to stay, feel free. If you want to go on, you know, do other things, feel free to do that as well.
All right, thanks. Have a good day.
You too. Okay, Sam, what you got for me?
Okay, so that answered one of my questions. So how about let's try. Okay, so this was integrating by parts, first section. So I've got the integral from 1 to the root of 3 times 5 tangent inverse of 1 over x.
Ooh, that's a good one. And we know it's integration by parts because it's an integration by parts question, right?
Yes.
Did it mention anything about doing a U sub first?
I don't remember. It probably did.
Because that 1 over x is puzzling me, right, essentially. So this may or may not work, but let's assume that it had that guy.
Okay.
Right. So that would be my U sub. Now, superficially, that's going to look like it's not going to work, but you have to hang in there. It will work. If you differentiate this guy with respect to x, you better call him x to the negative 1. So multiply by the power, reduce the power by 1. And again, negative powers are not really good for what we need, right? Now, if I do the cross multiply thing, well, I should call it the crossover thing. We get that. So there we go. So this is going to be the integral of 5, the inverse tan of u, multiplied by negative x squared du. So I need to know, I'm just puzzling for a minute, I need to know what x squared is in terms of u. Well, the only guy I've got to work with is that. If you do a quick math on that, would you agree it's that guy?
Yeah.
And won't that guy give me that guy?
Okay.
So I have 5 over u squared, inverse tan of u du. Now, I'm not happy with this, but I can live with it, I think. Because it's at least got terms that look like they might work with an integration by parts. I really quite like the inverse tan thing, but I don't like what this is going to become. So now that I
holds
it's
the
still
negative, right?
say again? Oh
It's
yeah, there's still negative.
Yeah.
Okay. So I'm going to hold that one for a minute, and I'm going to pretend that it didn't have a u sub in it. And I'm going to see if I can just do it the usual way. And then I'm going to look at the book and find out that better not be a table question, you know, where you're meant to just go to a table and do it. I mean, that, for instance. Okay, so let's see. I have to pick an F and I have to pick a G. Who would you choose?
Haven't done this in a while. Probably my G would be the which one? Which way does tangent go? So tangent.
Tangent's
So
a
I'd want
bad thing to
my-
integrate.
Yeah, I'd want 5 to be my G and F to be tangent inverse.
So don't normally do this, but there's F, right? Now, if you want to differentiate F, it's going to be 1 over 1 plus 1 over x squared times the derivative of 1 over x, which is negative 1 over x squared. So that is going to be negative 1 over 1 plus 1 over x squared times x squared. That's going to be negative 1 over x squared plus 1. I actually like that.
Yeah.
So it's going to be the integral of, it's going to be f of x, capital G of x, take away the integral of f dashed of x, capital G of x, dx. Now, f of x is that weird inverse tan. G of x is the integral of 5, so that's just 5x. Take away. The derivative ends up being that guy, and G of x ends up being this guy. So what we have is 5x, the inverse tan of 1 over x, plus 5x over x squared plus 1 dx. And I am really happy now. So my U sub did not work, at least at the start. I could have done an integration by parts with that, but it wouldn't have been nice. It would have just got worse and worse. So not a good idea. So plan B. Now, I still have work to do, but at least it's doable. How will you integrate that, fella?
I'd use a U sub, right? For the bottom.
So can you just trust me that you end up, this is a question where you do an integration by parts followed by a U sub.
Yeah, that makes sense.
And that's the finish.
Okay.
That just shows you, you kind of get some insight into how I tackled that. I kind of thought I'm going to use a U sub. And so I tried like a U sub first and see what it turned into, and then I didn't like what it turned into. Maybe the next time I see one like this, I remember and do this, the integration by parts first. That's pretty much it. Okay, we get anything else?
Yes.
Okay, what's next?
Let's try. Not that one. Okay, so this is from section 7.3, and it's problem number 6. And what it is it's the integral from 2 to 3 of dx over x squared minus 1 all to the third 3/2 power.
Okay.
Yep.
Right. We recognize this as what I call x subs.
Yes.
What x sub uses x squared minus 1?
Number 3, so x equals a secant theta.
In this case, 1 secant theta, right? So dx by d theta. Okay, what do you get if you differentiate a secant?
Secant tan.
Right, we're done. So as that's concerned. So it's going to be the integral of secant squared theta take away 1 raised to the power of 3 halves, and then a secant theta, a tan theta, d theta. Oh, I recognize this one now. Secant theta, tan theta. What's secant square theta take away 1? Because that is a nice guy.
It's tangent squared.
And tangent squared raised to the 3 halves gets you tangent cubed. You comfortable with that?
Yes.
And if you cancel one of the tangents, you get that.
Mhm.
Where do I go now?
Okay. Here, I'm writing it down.
Okay.
Tan theta. So bringing the tangent to the top and changing it to sine over cosine, or when it changes cosine over sine.
Great.
Right, because this, when you bring the tangent to the top, it should flip to cosine squared over sine squared, right?
What about the secant?
Secant is 1 over cosine. That cancels out.
So what you're left with is a cosine theta on the top, if we've got this correct, and a sine square theta on the bottom. Is that correct?
Yes.
Okay, where do you think you're going now?
What I believe I had tried to do was take the, I think I took a u sub of sine squared.
Yeah, that's the mistake.
Well, u sub of sine.
Oh, if you said that, then I agree. Can I tell you that one because it's easy to do?
Yeah.
If you integrate this guy, you should probably call it u to the negative 2, right?
Yeah.
So if you add 1 to the power, it becomes this guy. Add 1 to the power, divide by the new power, which becomes this guy, which then becomes this guy.
Yeah.
Now we have to go back to the x sub. And build our triangle. So that this can be converted into x's. So opposite, adjacent, hypotenuse. Right, if I call this guy x over 1, then won't 1 over x be the cosine of theta? Are you okay with that?
Yes, I am.
And that is adjacent over hypotenuse. And that makes this guy 1, makes this guy x, and this guy better be x squared minus 1. And he is. And although it's a while since we've seen it, does it not match the integral? So we know we're in the right tracks. Now, the answer we're looking for right now was this. Well, if you look at this picture, this triangle, won't the sign be opposite over hypotenuse? And since this is negative, the reciprocal of that, don't you get negative x over the square root of x squared minus 1?
Yeah.
And our integral is between 2 and 3.
I feel like I had gotten everything up to that point the same way and gotten the same answer up to there. But
Okay, let's take it. Okay, so it's negative 3 over the square root of 8. Take away negative 2 over the square root of 3. So what's that? Negative 3 over 2 root 2 plus 2 over root 3. I don't know if they tidied that up or not, but there's not much you could do to make it pretty.
Oh, that's lecture.
Just an arithmetic mistake.
That looks, here, I'm gonna see if I have my work right here real quick. I should have it. This is number 6, so I'll recognize that. I don't know where. Oh, here it is. I think that's not it. Darn. Is the other student right here?
Javon, you got a question, or you just forgot to leave?
I might have a question.
Oh, you have a question. Okay. So it looks like Sam's going to look for some stuff. So while he's doing that, what's your question?
So I'm not really clear on when to use the long division for the.
And when not to? Okay, let's show you. It's not actually that hard to explain. Here are two situations, one where you should do long division, the other one where you don't. And I've tried to make them almost identical, except in one key area. The biggest power of x on the top is 2. If I FOILed all of that out, would you agree that I'd get x cubes and some stuff?
Yeah.
In a situation where the top power is less than the bottom, there is no long division needed. Right? You just do it the usual way. In this second question, can you see that the biggest power is 4 and the bottom power is 3? When you see that, you do long division. So the rule is, if I say call this the top, call this the bottom. If the top power of x is equal to or greater than the bottom, you do long division. Now you might have to work on what the top and bottom power is. Can you see in this case, you'd have to imagine factoring that out to realize that was x cubed.
Yeah.
Now, sometimes it's not factored. Would that question need long division?
No.
Correct. Would this second one, this one here, would it need long division?
Yeah.
If they wrote the second one to try and trick you, for want of a better word, wouldn't you still need to do long division?
Yeah.
But you'd have to turn it into this to do the long division. Right?
Mm.
So there's your rule. If the biggest power of x on the top, right, the largest power of x on the top is greater than or equal to the largest power of x on the bottom, you do long division. Otherwise, don't.
Okay. Yeah.
Any other questions, Jiva?
That was pretty much it. I still need to get around to finishing most of the last homework assignment, so I'll probably have some after that.
Okay, well, it'll be a bit harder to get to me because the weekend's coming up, but I'll try and see if I'm available at any time for you.
Okay.
Okay, what you got for me? If that's it, bye-bye. Sam, are you good to go now? Or did you find your mistake or whatever it is you're looking for?
Okay, so I figured it out. I had just misplaced a negative sign. That was the only problem. I do have at least one other question, if that's okay.
Yeah, we can go for that, and then I'm going to have to call it quits because I have to get ready for my next class.
Okay.
But I have time for one more, so go for it.
Okay, so let's do, this problem is, should be quick. So
That's good.
It's from 7.4 and it's number 4, part 1. And what it is we have a fraction, and on top we have x to the 4th power minus 2x to the 3rd power plus x squared plus 5x minus 1. And then at its denominator, we have x squared minus 2x plus 1.
Okay, and I'm assuming you have to long division it?
Oh.
No? What have you to do?
Oh, that makes sense. That just answered the question.
Oh, that was very, very quick. Okay, what was your other one? Because that one hardly counts as a question.
So number five, same section. This is the integral from 0 to 1 of x minus 6, all divided by x squared minus 6x plus 8 dx.
What I noticed about this question is that I need to factor the bottom. And now it's a partial fraction.
I think this one was, okay.
Now, what may happen, and this may be where your problem happens after this, is that you're going to get answers with, I don't know what the multiple is, but you're going to get an answer with so many, whatever fraction, let's pretend it's a third, and maybe mine is a quarter of this guy, just for argument's sake. And now you're going to put in numbers 0 and 1, right? But they're not going to work. And the reason they're not going to work is because they're negative. This is one of those examples where you have to use the absolute value. So you would just find the absolute value of that, which would be the natural log of 1, which is 0, so it would disappear. And if you plug it into this one, it would be what? The natural log of -4, which would just be the natural log of 4. So that might have been what your problem was, because I don't see any real problem with this. Isn't this just a pretty straightforward integration by parts with 2 terms?
Yeah, I don't remember what my problem was. I know it wasn't the
It may have been the
value.
numerical bit at the end where you were trying to get logs of -1 and -4 and realizing that that wasn't going to happen. And the trick to do that is that the natural log should be the natural log of the absolute value of what you put in. which most of the time is positive, so we don't even notice doing it.
Yeah. I know that every time I did the natural, every time that I had ln of x and web signs so far, I've just put in natural absolute value signs, basically just
To keep them
to
happy.
be safe. Yeah.
Right.
So I don't think that was the problem.
Oh. It may be you lost a sign somewhere. It may be a
Yeah.
half should have been a third.
Yeah.
The process itself, I don't think should be that big. I could tell you what the two fractions come out to be. There's going to be an A on the first one, right? There's going to be a B on the second. And if you go looking at what's called the cover-up method, you'll find out the shortcut. Here we go. Well, we've been 2 years, that's -2 in the bottom. -2 in the bottom. -4 in the top, that's 2 of these, I believe. 4 in the bottom's 2, -2. Take away one of those. So you're going to have 2 natural logs of x, take away 2 absolute values. Take away 1 natural log of x minus 4, absolute value. Evaluated at 0 and 1. So that's going to be 2 log 1. Take away the log of 3 minus 2 log 2. Take away the natural log of 4. That's 0. So negative log of 3, take away 2 logs of 2, add a log of 4. That ends up being, as far as I can tell, that ends up being that. Because that guy and that guy are the same. They cancel out. So
Why
it's,
why do those two cancel out?
oh, because 2 log 2 is a log of 2 squared, which is a log of 4. And it's got a negative in front of it. So it's negative log 4 plus a log 4.
Oh, nice. Okay.
And it's actually so nice, I'm probably right.
Okay, I'm sure that will be enough for me to at least figure out what I got wrong.
Okay, so I'm
Okay.
going to leave
you.
now. You are welcome. Hopefully you don't have too many problems between now and the test.
Mhm.
I will see you on Monday.
Okay.